We need to solve this equation, which has two algebra fractions being subtracted on the left-hand side of the equation, the two fractions having linear expressions in both numerator and denominator, equals 15 on the right-hand side of the equation. I observe that my two algebra fractions being subtracted are exactly the same as the two algebra fractions that I subtracted and processed in my previous example. And if I were to process these two algebra fractions in the same way, I should end up with the same expression as I did in my previous example. So, if I replace the left-hand side of my equation with 20x squared minus 5x plus 20 over x squared plus 3x minus 4, I can then proceed with solving that equation. And that's what I will do. So, the left-hand side of the equation becomes 20x squared minus 5x plus 20 over x squared plus 3x minus 4, and that must equal my 15 on the right hand side. Now I have an algebra fraction on the left hand side equals a number term on the right hand side. The next step is to get rid of the denominator by multiplying both sides of the equation by that denominator. So I multiply both sides of the equation by x squared plus 3x minus 4. So the left-hand side of the equation is now just the 20x squared minus 5x plus the 20, and the right-hand side of the equation is now 15 multiplied by the x squared plus 3x minus the 4. I expand this bracket, so now I have 20x squared minus 5x plus 20 equals 15x squared. 15 times plus 3x is plus 45x, and 15 times minus 4 is minus 60. This is the form of a quadratic. To proceed with the solution, I have to collect all the terms to one side of the equals and make it equal to 0. So I now subtract 15x squared from both sides of the equals. I also subtract 45x from both sides of the equals, and I add 60 to both sides of the equals. So the left hand side of the equation now becomes 20x squared minus 15x squared is 5x squared, and minus 5x and minus 45x gives me minus 50x, and plus 20 and plus 60 is plus 80 on the left hand side of the equals. On the right hand side of the equals, all the terms are cancelled out and I get 0. I observe that if I divide all the terms by 5, 5 is a common factor, and I would get x squared minus 10x plus 16 equals, and 0 divided by 5 is still 0. So my equation is now reduced to a simple quadratic. To solve this quadratic, I have to factorize. A 3-term quadratic is likely to factorize in 2 brackets, and that's what I will attempt. So equal to 0. To get x squared, I must have x and x. I have a product of 16, so the product is equal to 16, and the sum is equal to minus 10. So I'm looking for two numbers that multiply together to give me plus 16 and add together to give me minus 10, and that is minus 8 and minus 2. Now I have two brackets multiplied together to give me 0. So either the first bracket is 0, the second bracket is 0. So either 8x minus 8 is equal to 0, or x minus 2 is equal to 0. And that gives me x equals 8, and that gives me x equals 2. And these are the two possible solutions to that equation. We're done.